Theoretical recap. On Linux, every process runs with the privileges of a user and its groups. The principle of least privilege dictates that an account should hold only the permissions strictly required for its tasks, nothing more. A pentester frequently launches tools, Nmap, Wireshark, custom scripts, that only need targeted capabilities, yet many practitioners lazily run everything as root, exposing the host to accidental damage or compromise if a tool is malicious or buggy. The mental model is layered. 1. The user identity, UID, and primary/secondary groups, GID, define who you are. 2. File permissions and ownership define what you can touch. 3. Sudo policies, via /etc/sudoers.d/ define which privileged commands you may escalate to, and under what constraints. 4. Linux capabilities let you grant a single privilege, for example, cap_net_raw_per packet capture, to a binary without full root. A restricted pentest user combines these to isolate risky tooling. Common mistakes: adding the user to the sudo/wheel group, granting full root, using no password carelessly across all commands, forgetting to restrict the home directory permissions, and running Wireshark as root instead of using the Wireshark group and setcap on dumpcap. Mini example: creating a user and granting only Nmap via sudo. Sudo user add ms/bin/bash pentester. Echo pentester all equals root. Nopassword /user/bin/nmap sudo t/etc/sudoers.d/pentester. Sudo chmod 440/etc/sudoers.d/pentester. This lets pentester run nmap with elevated rights while keeping the rest of the system off limits. Workshop brief. Your objective is to design, implement, and validate a fully restricted Linux user account dedicated to penetration testing activities. This account must be able to perform legitimate pen test tasks, network scanning with Nmap and packet capture with Wireshark/Chark, while being prevented from performing any general administrative action. You will apply the concepts from the previous chapters on user/sudoer management, package management, and scripting to build a reproducible, auditable setup. Start by creating the dedicated user with a proper home directory and a controlled login shell. Set a strong password policy or key-based access as you see fit, and lock down the home directory permissions so no other non-root user can read its contents. Document each command and the reasoning behind it. Next, define a precise sudo policy. The account must be able to run Nmap, which needs elevated privileges for SYN scans, through a tightly scoped /etc/sudoers.d/file. Decide deliberately whether to use nopassword, and justify your choice in your report. The account must not be a member of the sudo, wheel, or admin groups. Verify this explicitly. For packet capture, avoid granting root. Instead, configure the Wireshark group and apply Linux capabilities, setcap, to the dumpcap binary so that the pentester can capture traffic without full privileges. Add your restricted user to the Wireshark group and confirm capture works. Then attempt a forbidden action, for example, editing /etc/password or installing a package via apt/dnf, and confirm it is denied. This negative test is as important as the positive ones. Finally, write a bash provisioning script that automates the entire creation process: user, sudoers entry, group membership, capabilities, permission hardening, so the account can be reproduced on any fresh host. Make the script idempotent where possible, add basic error handling, and include comments. Produce a short verification checklist demonstrating, with command output, that each permission is granted or denied exactly as intended. Submit your script plus a concise report, screenshots or terminal transcripts, proving your restricted account behaves correctly.